Hi guys, it's me, Charotera once again. Our topic for today is about inverse variation. Last time we have tackled direct variation, and if you wish to go over it once again, feel free to click on the link in the description box below. Now, as previously discussed, in direct variation, as one quantity increases, the other quantity also increases. On the other hand, as one quantity decreases, the other quantity also decreases. In short, they move in parallel direction. Now, in inverse variation, from the word inverse, the opposites happen between the two variables. This means that as one quantity increases, the other quantity decreases, or as one quantity decreases, the other quantity increases. Now let us once again consider a construction industry. Presuming that you are hiring workers to construct a building. The relationship between the number of workers and their total wage for the week is a direct variation, since the more workers you hire, the more you will pay for their wage for the week. Hence, the lesser the workers, the lesser the total wage you will pay for the week. Now, which do you think are the variables that are inversely proportional in this situation? Well, let us consider the number of workers and the number of days it will take to finish the construction of the building. The more workers you hire, the shorter the days it will take to finish the construction of the project. But the lesser the workers you hire, the longer the days it will take to finish the job. Now, if you observe, as one quantity increases, the other quantity decreases. On the other hand, as one quantity decreases, the other quantity increases. This is an inverse variation. Now, how do we write inverse relation as an equation? And how do we compare this with the direct variation? In direct variation, if y varies directly as x and k is our constant of variation, we write y equals k times x. Now in inverse variation, if y varies inversely as x, we write y equals k over x, or divided by x. That is multiplication in direct and division in inverse. So again, when we say y varies inversely as x, or y is inversely proportional to x, we write y equals k over x, where k is our constant of variation. Now let us have this example. Suppose you are planning to buy a rectangular residential lot that has an area of 360 square meters. Complete the table of values that will show the relationship between the length and the width of the land. Now, based from the situation, the area of the rectangular lot is our constant of variation since it is fixed to 360 square meters. Given that if the length is 24 meters, the width must be 15 meters to have an area that is 360 square meters. Now, how if the length is 30 meters? Now, to get the corresponding width, we simply divide 360 by 30, so we get 12. Same thing we do for the rest. So for 36, we have 10 as the width, and for 45, we have 8 meters. So you see, based on this table, as the length increases, the width decreases. And since the opposites happen between them, we say that the length of the rectangle is inversely proportional to its width, or the length of the rectangle varies inversely as its width. In symbols, we write L equals kW, where the length is L, K is the constant of variation, and W is the width. Now let us have some exercises. If M varies inversely as T and m is 16 when t is 5, find k, or the constant of variation. Now it says there that m varies inversely as t, so we write m equals k divided by t. Excuse me for the roosters. And m is 16 when t is 5. And we are asked to solve for k. So what we're going to do is we simply substitute these values to the equation. So we will have m, since it's 16, we will replace that with 16 equals k is the unknown and t is 5, so divided by 5. We can deal with this equation using ratio and proportion, and the denominator of 16 is 1, and then we cross multiply. 16 times 5 is 80 equals 1 times k is 1k, or simply k, and then by symmetric property we have k equals 80. So the constant of variation in this problem is equal to 80. Now let us have this problem. The number of revolutions of two pulleys, represented by letter R for revolutions, is inversely proportional to their diameters. If a 24 centimeter pulley making 400 revolutions per minute is belted to an 8 centimeter pulley, find the number of revolutions per minute of the smaller pulley. Now in the problem it says that the larger pulley has a diameter of 24 centimeters and makes 400 revolutions per minute, and it is belted to a smaller pulley that is 8 centimeters in diameter. The question is, how many revolutions per minute will this 8 centimeter pulley make? We now have all the information needed to solve this problem. So what we're going to do now is solve for the constant of variation in the equation r equals k over d. So let me just copy that again. R equals k over d. Since we are going to solve for k, we multiply both sides of this equation by d for the purpose of eliminating d in the denominator. So d times r, we have dr equals d divided by d, that is 1, so we have k that is left. Therefore, the constant of variation from this equation is k equals dr. We now have the constant of variation, which is k equals d times r, and this is what we will be using to find the revolutions per minute of the smaller pulley. So again, k equals dr, that is equal to another dr. So we will be using dr for this portion and dr also for this part to solve for r. So let us substitute. D is 24 times r is 400, so we will have 400 equals another dr for the smaller pulley, so d is 8 times r is the unknown. So we have 24 times 400 equals 8 times r. To solve for r, we divide both sides by 8. So this is 1. We have r equals 24 divided by 8, that is 3 times 400 is 1,200. So that means the revolutions per minute of the smaller pulley is 1,200. And there you have it, guys. Thank you for watching. I hope that this video made help in your quest for understanding what inverse variation is. If you want to see more of my videos, please subscribe to this channel and don't forget to hit that notification bell for updates. Thank you.